Hello students, I'm back. Last day we had done functions. I've done one program and I have given you three programs. So today I will be solving all those three programs and maybe I can give you some more. But today I will try to complete that void functions so that next day we can go to another type of function, the functions with return values, right? So the first program to print prime numbers from 1 till n. Now uh, I will be using BlueJ method. Suppose class name is fun, void main. Now I will try to explain all the program using this program only. My class fun will be same, void main will be same, and for first two programs this for loop will be also same. Now I have taken class fun, taken a function main, n is my input, started a loop from 1 till n. Why 1 till n? As you know, because we need prime numbers from 1 till n, and I can have any method name. It can have with my name also. I can have method name Ajam or anything, right? But since we are looking for prime numbers, right? So I am calling a method called prime. If you remember table, what we had written, we had written table I. I have written here prime I. Just this writing won't help. If I write prime I, this doesn't mean that you will get prime numbers. Now I have to define this function prime. In the same way, if you had a function to print perfect numbers from 1 till n, you will just write here perfect I. You will just write here perfect I, prime I or perfect I, perfect I. This will print prime numbers from 1 till n, and the second one will print perfect numbers from 1 till I. I hope you know what is a prime number. A prime number is number which has two factors. You know what is a perfect number? Perfect number is a number whose sum of the factors equals to the number. For example, 6, the factors are 1, 2, 3. Don't include 6. You will get 6. 28, the factors are 1, 2, 4, 7, 14. Add them, you are getting 28. So, the first part is clear. I will be writing just two functions, void prime and void perfect. Is that clear? So, I am running this. I will just write now the function part. I hope you all have done prime numbers program in now class 9. What I have taken? I have taken x, void prime. This is my return type, name, argument. I have to check whether x is prime or not. This part is clear. You know how to start a loop. For prime number, normally I count number of factors. I don't use any flag method. If x mod I equals to 0, c plus plus is the number of factors. If c equals to 2, system.out.println x is my prime number. My class ends here. Now, if you continue from there, you have void prime I. Now prime is being defined. Void prime int x. What is happening in this program? I am starting a loop from 1 till x, checking for factors and counting. If I am getting two factors, I am printing it. Right? Suppose if you will enter 10, you will get all the prime numbers from 10. First, it will check 1 whether 1 is a prime number or not. If it is a prime number, 1 will be printed as no output. Again, if I will become 2, this 2 will go here. It will check prime number for 2. I hope the concept is clear. Now, same way, you can copy this, right? I will do a little bit of changes. I will get the answer of the second program, that is perfect number. Perfect number from 1 till n. One more thing, why we are using functions. These programs we have done in class 9 using nested loop. Function means modules. It breaks our code into simpler parts and sometimes also helps in a good logic, breaks the code into simpler parts. And one function can be used more than once. It also saves our time. So second part I am running here only. I am just converting this into perfect function. See, the prime, it became perfect, or whatever name you want to give. This, see, I am using S. I am removing this equals to. You know what is a perfect number? Sum of the factors. This S is giving you sum of the factors. Now you are checking whether the sum and the numbers are same or not. So it's done. You are getting perfect numbers also, right? Suppose in the main you write start a loop from 1 till n. Start a loop. You start a loop from 1 till n, and then call this method perfect, and you will get. Just I'm using. We have learned this perfect number in class 9. I am using it in a different way. Now the last program which I gave you, is print all 3-digit Armstrong number. So I'm running this and I will be doing that program. Void main, no input, because what I have told print all 3 digits. So starting a loop, I hope the loop part is clear. Arm I or Armstrong I, whichever you find easy. The first part is done, and this is the new thing you are learning, because I hope all of you have done Armstrong number before. Now defining the function. This part is calling actual parameter, formal parameter. Total is function header or function prototype, and this one is known as function signature. I hope you are acquainted with Armstrong program. Some of the cube of the digits. Same thing I am doing. I will just check if S equals to the number. I will just print the number. I hope you understand why loop from 100, because I have told you to print all 3-digit Armstrong number. Loop starts from 100, goes till 999, calling the method Armstrong I, closing this main. Now Armstrong is not a inbuilt function, so I am defining it. Void Armstrong, int x is my argument. Now I am checking whether x is an Armstrong number or not. Declaring the variable d, taking some 0, and duplicate value of x is taken in m. This part, while m is greater than 0, or you can use not equal to 0, extracting a digit, doing the sum of the cube of the digit, truncating one digit. Suppose number is 153, then it will become 15 here. It will continue, again you will get 5, again the loop will run 3 times, and you will get the sum 3 square plus 5 square plus 1 square, whatever. Then finally checking if the sum and your number are both same, it will be printed. So I hope these 3 programs are clear. So for next day, I am giving you some programs. You all can practice. At home, because the next class will be on return type. You will not be doing void functions. You can do prime factors of a number, Fibonacci, which are prime till n terms. And the last, print factorial of each digit. Print prime factors of a number, Fibonacci, which are prime till n terms. Print factorial of each digit. If you have a number say 123, you have to print factorial of 3, 2, 1. Fibonacci series, you have to print those numbers which are prime in that. Okay, till then you study this, and again we'll meet. Then we'll be doing functions that will be returning values. Okay, tata, take care.